Hello friends. Today I'm back again with respect to showing you a new video that is focused on exploiting the ActiveX component as a part of the IE. So an ActiveX is basically a DLL module that's basically installed into your computer, and Windows has a specification of COM objects called communication objects or common object model, which basically allows certain ActiveX objects or certain DLLs to be called from Internet Explorer. This allows basically for Internet Explorer using these DLLs to execute actions that are not directly possible for a web application to do. For instance, one could basically allow um, multiple upload of files, or allow basically a functionality to a specific web application to install some kind of web filtering device in a way. So basically, if you're trying to log in into an application, this application can install an ActiveX component so that it ensures that when you're typing in your username and password, no other DLL is trying to sniff I'm sorry to sniff or snoop on the username and password. So I mean, the ActiveX functionality can vary from uh, it can vary basically from different functionalities based on the aspect of the application. Another instance could be it could provide, for example, a web application to open up a POP SMTP SMTP window so that you can actually send your emails, or use POP to actually check your emails. There are different DLLs. There are different ActiveX functionalities that are provided by different applications. Today we are going to look at one of the ActiveX DLLs, which is called an Advanced File Vault. Basically, this allows you to lock up any files or any specific folders on your computer by using a password. So it sort of encrypts the content and allows or disallows you to lock basically a file or unlock a file, so that way you can store that securely. In addition to that, it does provide an ActiveX component so that it can do the registration and other aspects that need to be done. This specific issue was already identified on the exploit DB, and this specific exploit sort of does exist on exploit DB as well. My intent over here is to sort of go over how you can identify these ActiveX DLLs, and then how you can basically, using Sulley in my case, fuzz the various methods that are provided by ActiveX components. Because the good part is that from an attacker's perspective especially, is that you have a X number of methods are exported out, and basically JavaScript can be used to call these X number of methods. So if one of this method is susceptible to a buffer overflow attack or some other form of exploitation, it's trivial to exploit a user's computer by tricking the user into navigating to your web page which has this exploit, and then basically performing an exploit against that user's computer. Obviously, the whole intent is based on the fact that the user has to have that specific ActiveX installed on his device. Um, so one common way of figuring out after you install a specific application, so in this case the Advanced File Vault was installed, and what I intend to do is use iDefense Comraider. This is actually a uh, very good ActiveX fuzzer, and I recommend for the people who are starting to work with ActiveX to actually start using this to fuzz specifically the ActiveX methods, because it does provide a fuzzing um, mechanism that can be used to actually fuzz rather than using Sulley. The only problem with that is that you get a better control over what kind of methods you're fuzzing, and control over the arguments that you fuzz much more easily if you're using Sulley as opposed to using the Comraider. However, I would still recommend that Comraider is pretty good, and it does identify most of the vulnerabilities that you would identify with Sulley or any other aspects. So basically, you have to install Comraider. Just download the Comraider by googling it up, and you'll get a zip file. You should be able to install Comraider. Once Comraider is installed, basically at that point of time, what you want to do is select the first option, which is choose ActiveX DLL or OCX file directly. At that point of time, so this is the folder where Advanced File Vault is installed in my computer. I identify where that is installed on yours, and try to identify which DLLs can be accessed by Internet Explorer. That means a JavaScript code. File does not contain a valid type lib, so that means that this cannot be accessed most likely by using ActiveX component. Let's try this one. Same issue over here. So this is a good part that helps you to eliminate what DLLs you need to look at in case. So we have looked at 3 DLLs that are present in this Advanced File Vault folder, and they are not fuzzable basically at this point of time. However, we have this specific DLL called eSellerRate Control 350.dll. This DLL does open up, and these are basically all the methods that are supported by this DLL. So basically, you should be able to fuzz, directly. So if you were gonna actually, use Comraider, all you need to do is just select one of the methods and say fuzz library, and then just select next, and these are all the fuzzing files that are generated. Comraider does provide you, direct functionalities to start fuzzing, and it does note the exceptions that might get generated, and that should help you to, determine if there's a buffer overflow or something similar in nature. However, my method is based again on using Sulley. Sulley is obviously an application level fuzzer that can be used for fuzzing network as well as file level protocols. So I'm going to use that specifically in this case and try to show you how you can use Sulley to write a simple fuzzer that can be very helpful for us. In case if you need to know how to install Sulley, please check out my other video that talks about how to install Sulley and also gives you basic idea on certain components regarding Sulley. Alright, so we are looking at different methods. Obviously it becomes a little bit tedious to do this manually because in Sulley you will have to provide the method name and as well as what argument needs to be fuzzed. However, once you do that, it's much more easier for you to start fuzzing in your own way. So in this case, one of the methods that's susceptible to buffer overflow is this get web store URL. You can get the definition of the method, so it seems like it uses 2 things. One is a publisher ID, which is a string, and another one is basically also a string. In this case, it seems like this method is susceptible to buffer overflow. So what I'm gonna do is basically use a Sulley fuzzer that I've written for this specific method and create the fuzzing files that are required for Internet Explorer. So let's look at the Sulley fuzzer that I've written for this one. Basically all I'm doing is importing Sulley over here and importing sys and OS modules. At that point of time, initializing the OCX, and then basically this is, if you look at it, it's basically HTML with JavaScript in it that I have basically added to the Python Sulley fuzzer. What I intend to do is basically, note the class ID. This class ID is going to be the class ID that is similar of your eSeller interface, eSeller interface, which is this GUID. So this is basically how the operating system knows which COM object to call and which specific method to, basically access. Everything else seems normal. Basically, everything is static. However, so in this case, I was doing for another method as well. So you will actually see this is for another method, but the idea still remains the same. In this case, what I'm doing is keeping the argument 1 as static. However, the value of argument 1 is what is going to be fuzzed, and then similarly the value of argument 2. And since this method takes 4 arguments, I'm actually fuzzing all the 4 arguments, which are all string arguments for this one. However, in our case, if we were doing the get web store method, the get web store URL method, all we would need to do is change this aspect, remove these two components, since we only need two in this case. What I plan to do is I'm gonna just do the first method as my first value as opposed to the second argument. I'm going to leave the second argument as static value, which is the default v value over here. Once that is done, uh, this is basically a simple module. I'm sorry, a simple make directory command that basically creates a directory with the name of the method, so that it's easier for me to know which method do I need to look at, and then basically I'm mutating over the Sulley's first values and then storing them directly as an HTML file. So if you look at it, in this case, I already have one that I know works, but for the sake of this demo, I'm also gonna create this. So let me go over here, and then let's go back. Sulley uses Python 2.5, so I'll be using that. And then basically at this point of time, call the Python method that we have, the file that should create basically all the first values. So that is very easy with respect to using Sulley. You can obviously automate the aspect of opening Internet Explorer and then opening that specific file by either using command line scripts or even Python. In this case, I'm going to do that manually just because it's easier for me to do it when I show it to someone else. But you can basically automate. So if you can look over here, these are all the HTML files that have the first values. And if you want to check, let's take an example of this one. Basically, it's very simple. As I said, that this is an HTML body script. All I'm doing is basically adding the argument 1, which is first in this case, and then calling with that specific argument. So that's as simple as it is. Now, to test these values, I'm going to close the Comraider at this point in time. You could use Immunity Debugger. This basically is useful because of the core lands provided mona.py module as a part of Immunity Debugger, which you can have it as so that way it makes exploit writing really easy for Windows. It provides mostly all the methods that you require in terms of finding jump pointers or SEH pointers that you need, and that is really useful when you start doing exploit writing as a part of your daily routine. So what I intend to do now is open up Internet Explorer and then let it run. Now what I intend to do is just arrange my things according to the size, just because that way it's easier for us to know which specific file will cause it to crash. So in this case, this is a 1 KB file, which means that there is not any value that's fuzzed at this point of time. And just expand it, and that did not cause any crash, which was expected. Usually you will not see anything crashing for like a 1 KB file. It's very rare that if that happens. Let's try with a 2 KB file. And when I say 2 KB, so here we go. As soon as it's 2 KB, that has caused a crash. And you can look that we actually directly control EIP. So this is a good scenario. In this case, it's just very easy for us to know that this is a classic example of Stack Overflow. If you look over here, we do have the stack covered with 4 1s, 4 1s, which are all the A's. So we're going to take a look at this one and see. So there you go. The argument 1 is just filled with 2008, character values. Now, the good part of using Immunity Debugger is that what I can do now is, since I know that it's 2-byte value, this is another exploit that I have created. Which is a ready-made exploit now at this point of time that I had created for this specific module. But what I'm going to do is I'm going to show you the methodology that you can use to actually start doing an exploit. So now we need to figure out where exactly, so we know that this is 2000. Where exactly does the EIP get controlled by us? So we basically need, in this 2000 byte payload, the offset where it can be controlled. So one way of doing that is actually asking immunity the Mona. So you have to basically just install Mona. You can look for the instructions for installing Mona on CodeLab's website. But basically all you need to do is use Mona and then create a pattern of 2000 bytes. And Mona should create it in the main directory. So all I need to do at that point is go to my Mona directory and then look for pattern.txt file. That's where basically it does provide. So I'm just going to quickly go, and there you go. There's a pattern.txt file. It has created something with 2000 bytes. I'm going to take those 2000 bytes and then just point it over here. Now the argument 1 is filled up with 2000 bytes. It's the same thing as you saw earlier. We will block this since we don't need this, and then basically call argument 1 and argument 3, which in this case is 1, but it doesn't make a difference. So the argument 1 is the reason that it's resulting into a buffer overflow. Now, since we know where it is crashing again, basically refresh immunity debugger, go let the Internet Explorer start, and then basically at that point of time use our newly created HTML file, and so this has crashed, and we can look that this is EIP 68423268. So now what we can do very easily is use 0x68423268 2000. And now Sulley should tell us, Immunity Debugger or Mona should tell us that after 997 bytes we should be able to control the EIP. And so now if you look at my original exploit, you can see that I have something over here up to 997 bytes, and this is the pointer that has the values which point to a jump EBP instruction. I'll get to the reason why I'm using jump EBP. So basically this is a classic example of stack overflow, as I had said before. However, you have to note that since you're calling you're providing ASCII values and non-ASCII values basically at this point of time, it is required that you use an escape function so that you can provide the non-ASCII values in JavaScript. So you can see that this is a calculator payload that I have created for this module, and then basically I'm calling jump EBP. So let's look at the exploit. Why do we need to call jump EBP? So if you look at EIP, it does point to 68423268, and basically that should be in this. I'm gonna try to put this. So let's do 68423268. I'll try again 68423268. Okay. So if you look over here, ESP is actually pointing over here. However, our module actually starts from this specific area. And so there's a gap of about 1, 2, 3, 4, 5, 6, 7, 8, almost 10, so 40 bytes difference. Now if I had used a jump ESP instruction in this case, the problem is that it would have jumped over here, and then this is the part that we do not control, and that means that we lose the exploitation aspect. However, if you look after software, if you look at EAX over here, this is where basically our payload resides. And if you look, this is the payload that we have. However, we do have the software reseller affiliates area that is gonna be a problem for us, because this will result into a different set of instructions that we don't want possibly to get executed. However, if you look at EBP seems to be at a place, if you follow in stack, where we have control of the payload completely. And so it would be easier for us to actually, pivot towards EPP and then basically control the execution flow, which will result into popping of the calculator. So going back to the original payload, so that if you look at, that's why this instruction calls. So when we restart again, I can pause at that instruction, and that will show that it basically is a jump EBP instruction. And then once the jump EBP instruction is called, we call a couple of knobs so that it will follow these knobs and then finally execute the calculator payload. Right, so let's do that. So search for that instruction. So yeah, it is push EBP return, which is equivalent to doing a jump EBP. Now, if I needed to search for this instruction using Mona, all I need to do is type in J minus R, provide the register, which is EBP, and then minus N and minus O, which means that I don't want anything as null bytes, and then dash O would mean that do not give me anything from Windows, do not give me any pointers from Windows module, so only from the module. But however, since this is an ActiveX, we will need to use pointers from from the Windows modules. So that means that our exploit would be restricted to this specific XP version, and we'll have to create different exploits for different versions of Windows. But still, this is a good deal with respect to identifying pointers by using Mona. So this should work very quickly, and it should create you a file similar to this called jump.txt. And if you look in one of these modules, this is one of the addresses that we have chosen for our exploit. And so, like I said, using Mona does make our life a lot more easier to exploit something. And so now, since we have paused over there, I'm going to use my original exploit, which was this one, and just point and drag and drop over here. In a real life scenario, a user is going to go to your URL, which is equivalent to doing this. And so, as we can see, it has halted breakpoint at our instruction. So what I'm doing is using Shift F7 to pass the exception, return, and like I said, now it goes into the knob area that we control. We execute the knobs, and then finally, there you go, the calculator is popped up. So this basically concludes the usage of Sulley and then exploiting ActiveX using Sulley. This was an example of classic Stack Overflow, but you can use the same methods that I had talked about as structured exception handling, or using ROB techniques, or using heap spray, especially with ActiveX to bypass ASLR as well. So that's it from me today. Thanks again, guys.